All right, so the dividing out technique. What if direct substitution doesn't work? There's got to be another way to solve it, right? All right, so here suppose we're looking for the following limit. The limit as x approaches negative 3 of x squared plus x minus 6 divided by x plus 3. Yes, that's the direct substitution. If you take what x is going towards, the approaching, that number underneath the limit, and you plug it in, that will sometimes tell you what the actual limit is. But sometimes it doesn't. Like on this one, you can see here that when they plugged in the negative 3 for the numerator, right here, they ended up with 0. And when they plugged negative 3 in the denominator, they got a 0. Well, can we have 0 in the denominator? No. So the resulting thing was 0 over 0, which has no meaning as a real number. It's called the indeterminate form, and which doesn't mean it's a no solution. Okay, doesn't mean there's not a limit. It means, hold on to that. It means that we can't find the limit using that method. So we've got to find another method, okay?
Let me say the method.
So, but look at this equation. Just as it's written, if we put it in our calculator and we look at our table, look at what number. Does it appear that it has a limit as we look at it from the left and from the right?
Yes.
Yes. What number does it look like it's going towards?
-5.
Looks like it's going to be -5. So we can't see that there's not a limit. But what it tells us, if we get that 0 over 0, that there's something else we can do. And in this case, Emily already brought it up, is it might have a common factor. Can we factor it? Well, we're going to try that. All right, so after we factor and divide things out, then we're going to use our direct substitution again. So let's look at example 1, and we're going to use our dividing out technique.
Can you cancel the...
All right, so when you get one like this, the first thing you need to do is you need to go ahead and check your direct substitution. So let's do that here. So we'll remember our steps. So the first thing is direct substitution, because a lot of times it works.
Can we just do direct substitution on calculators to take up less room?
Yeah, but you might want to write down what you're doing. All right, so what are we going to plug in? All right, so I've got -3 squared plus -3 minus 6 over -3 plus 3. So work that out. 9 minus 3 minus 6 over 0. We already know we're in trouble, but keep going and we get 0 over 0, which is not good. It means it didn't work, so we got to find another way. Well, I look at this one, and we saw that it is factorable, correct? So the next thing we're going to do then is we're going to factor. So let's take that x squared plus x minus 6 over x plus 3, and let's factor it all the way down. So we factor the numerator. So we get x plus 3 times x minus 2 over, I can't do anything in the denominator, so I get x plus 3. Can I do anything with that? I can cancel that right there, and we're left with x minus 2. What is that called that I canceled? What is that going to be on my graph?
A hole.
It's going to be a hole, okay? So this is kind of like if you looked at the homework, which most of y'all did not. I think it's number 7. You'll see it had a hole on it, okay? No big deal. Once you get that simplified, then we're going to use direct substitution again. And this one you have to write down. So the first thing I want you to do is we're going to rewrite the limit part. So we're going to take the limit as x approaches -3 of my reduced fraction now. What did it reduce to? The x minus 2. And then use your direct substitution. So plug your -3 in for x. And what do we get? The -5 that we saw in the table we looked at previously.